Today I'm gonna show you how to add self-refill onto a percolator. But first, let me explain how I came up with this idea. Every day when I wake up in the morning, I like to start my day with a nice warm cup of coffee. Most days I remember to refill the percolator, but when I don't, it can get quite frustrating. Then I thought, what if I design a self-refill mechanism which will fill up the percolator every time the water level gets too low? To control the water flow, we'll be using a solenoid valve, which is just like a regular valve, but is controlled by electricity. Next, I'll tap into the tank from the percolator, using some plumbing I put together. Basically, this side will be sealed against the tank, while the other side will have a tube running to the solenoid valve. In order to sense the water level, I'll be using these digital water level sensors. These sensors come with 3 pins, one for ground, one for 5 volts, and one for signal. It also comes with a nut and silicone washer in order to keep it sealed against the surface of the tank. For those sensors, I put together a SR circuit, which stands for Set Reset Circuit. So if I hook up 2 sensors to the circuit and dip it in a cup of water, as you can see, when the low level sensor leaves the water, the LED turns on or the Set Reset circuit goes into set mode. And now for the LED to turn off or get the circuit into reset mode, the high level sensor has to hit the water. Now that we understand how the circuit works, we can now proceed to building the circuit on a circuit board. While doing that, I will be replacing the LED with a MOSFET, which can switch high currents compared to the IC. Now that the circuit board is done, we can now move on to the power supply, which is a 12 volt 2.5 amp power supply. Since we only need the power supply board, I'll split the enclosure in half, chop the main wires, and there we have it. Now, due to the fact that the water level sensors cannot take a higher voltage than 5 volts, we'll use a buck converter to lower the voltage from 12 volts down to 5 volts. Now that all the components are ready, we'll test everything out. This time, we'll use compressed air to simulate the water flow. It works! So now we can make the holes for the water level sensors. We'll first start by marking the holes, then use a center punch to prevent the bit from sliding, and finally we'll drill the holes using a step bit. Now that all the holes for the tank are made, we can head on over to the 3D printer. I would like to talk about the main features of the enclosure I designed. The first feature is a design of having the outer wall of the first part slightly smaller than the inner wall of the second part. The second feature is a curved design at the bottom of the enclosure, which makes it sit flat against the percolator. Now that that's out of the way, we can move on to mounting the enclosure. For that, I'll be using some rivets. Next, we'll mount the solenoid valve. I'll be using a L bracket and drill some holes for the rivet and the bolts. Now that the solenoid valve is strongly mounted, we can move on to packing all the electronics into the enclosure. To protect the wires going from the enclosure into the solenoid valve, I'll use a cable gland. I'll install another one for the pair of wires going from the enclosure to the percolator. Because the sensors will be running very close to the hot water tank, I'll use some silicone tubing to protect it from melting. If you're wondering where the power supply will be getting power from, I soldered a 2-wire cable onto the input of the power supply and ran it down to the bottom of the percolator where it got soldered onto the power input of the percolator. Now that all the electronics are done, we can screw the enclosure shut. To finish up the plumbing, we'll hook up a piece of silicone tubing going from the tank to the solenoid valve and thread on a water valve onto the solenoid valve. For the final step, we'll tap into a water line closest to the spot where the percolator will sit. Run a 1/4 inch flexible pipe all the way up. Hook it up to the input. Plug in power. Turn on the valve. And now, let's give it a test. As you can see, while the percolator is above 3 liters, it will continue refilling this pitcher with no problems. And when the water level goes below 3 liters, the self-refill mechanism will kick in and start filling the percolator with water until it fills up. I did end up adding a micro button for having the option of activating it manually, and a micro switch to be able to shut the self-refill mechanism. Well, if you like this video, then please subscribe to my YouTube channel and hit the notification bell in order not to miss any of my new videos.